Hello class, welcome to lesson 8.4 on similar triangles, SSS and SAS similarity. So our essential question is to use these two theorems, okay? So we're going to ask ourselves, or the essential question, how do we use SSS and SAS similarity theorems to solve problems and prove triangles similar. All right, so that's what we're looking for. So last time we talked about AA similarity, and now we're going to talk about these other two, SSS and SAS. So how does it work? So for theorem 8.4, SSS similarity, for it to work, we have to have that all three sides are proportional. Okay, so if the corresponding sides of two triangles are proportional, then the triangles are similar. Okay. All right. So what does it mean to be proportional? That means, for example, if this is 10 and this is 5 and this is 8, then this has to be 4. 10 divided by 5 and 8 divided by 4. All right. So for example, 10 divided by 8 is the same thing as 8 divided by 4. Or I'm sorry, 10 divided by 5 is the same as 8 divided by 4. And then, for example, this could be 6, and then this could be 3. So 6 divided by 3. In this case, these two triangles are proportional, right? There's two sides. The three sides are proportional, SSS, SSS. And therefore, these two triangles must be similar by SSS similarity. Okay? So hopefully that makes sense. All right, so if we have two triangles, how do we determine if they're similar by SAS? Well, we need the two sides to be proportional, and then the angle between the two sides has to be congruent. So these two have to be congruent. Okay, so in this example, we got these two are congruent, so we got the angle, that part is done. And then we need to look at the sides. So for example, if this were 10 and then this were 30, and then this were 6, and this is 18. Well, then you can see, okay, well, 30 divided by 10, if I match those two sides, is 3. And then 18 divided by 6 is also 3, right? So these are both the same. And therefore, the two sides, these are proportional, and then these are proportional. And so we got SAS, SAS. And so therefore, the two triangles must be similar by SAS similarity. Okay, so if the lengths of two sides of a triangle are proportional to the lengths of the two sides of another triangle, we're going to say proportional to the lengths of the two corresponding sides of another triangle, and the included angles are congruent, then the triangles must be similar. All right, so example 1, we use the SSS and SAS similarity theorems. So determine whether these are similar or not. Well, clearly there's no angles. We don't have any angles here, so we're going to see if it's similar by SSS. So let's see if the sides are proportional. So we can see that JL, and let me just use colors here. So we can see that JL is matches up with, how do we know which one matches up with what? Well, first off, you know that the biggest side matches the biggest side. So we know that this side, which is 16, matches the biggest side here, which is 12. Okay, so we can see that JK matches up with QP. So the biggest side goes with the biggest side, so 16 over 12. And then the medium side goes with the medium side. So that means the JL matches up with MQ. So 12 matches up with 9. And then we have this right here matches up with this right here. So 8 over 6. And then we can reduce these fractions. So we can divide by 3 here. So we get 4 thirds. We can divide by 2 here. We get 4 thirds. And then we can divide this one by 4. to get 4/3. So notice that these all match up, right? So these are matching, and therefore by the SSS similarity theorem, those two triangles must be similar. All right, so let's look at the next one. Go ahead and pause the video, see if you can try to check. All right, so for the check, determine whether the two triangles are similar. Explain your reasoning. So notice first off, right off the bat, you see this X right here. So you should think vertical angles. So we got these two angles are congruent, okay? So we're gonna say those are vertical angles. So these are congruent. So we got ourselves A for angle. And now we need to look at the two sides to see if they're proportional or not. So notice that this side is, if I double it, I get 20. And then this side, if I double that, I get 22. So we have proportions, right? So we got that 20 is to 10 as 22 is to 11. So that checks out. And therefore we have side, angle, side, side, angle, side. Therefore, they have to be similar by triangle, by angle, by SAS. Okay, so we're going to say triangle TWZ is similar to triangle. Now we got to match these up. Okay, so TWZ. Now we know that TW matches up with YW, so it has to be YW, and it helps that I color coded it. And then so then YWX here, and then TWZ. Okay. All right. All right, so they're similar by SAS similarity theorem. Okay, so example 2, parts of similar triangles. So find QN and PO, justify your answer. So step 1, show that the two triangles are similar. So are they similar first off? And the answer is yes. If we look at these two sides are parallel. And because they're parallel, that means this is congruent to this, and this is congruent to this, because they're corresponding angles. And so, therefore, by AA similarity, those two triangles must be similar. In addition, okay, so another way of looking at it, which is what the book shows here, is that, well, this angle is congruent to itself by reflexive property. And so we got ourselves an angle here. And then now we have two triangles, this small triangle and then this big triangle, right? So we have this small one here, but then we also have this big triangle. And so this small triangle right here, this is 5, and that matches up with this over here, which is 8, right? And then this side, which is 6, matches up with this right here, which is 6 plus 3/5, right? Which is 9 3/5. Okay, let me just write this as a decimal. 3 3/5 is 3.6. So then 6 plus that is going to be 9.6. All right, so let's see if those are proportional. So 8 is to 5, and then let's do 9.6 divided by 3.6. Are those the same fraction? Let's double check that, okay? So let me do that. Let's do that over here. Okay, so 8/5 is 1.6. And in fact, do that over here. So 8/5 is 1.6. Now let's compare that with 9.6 divided by 3.6. Oh, I put 3.6, not 3.6. It should be 6, okay? So 9.6 matches up with 6 here, okay? So they should say 6, not 3.6. Sorry about that. Okay, so let's fix that here. So 9.6 divided by 6. And look, they're the same. 1.6 for both of them, right? And therefore, these two sides have to be proportional. So we got side, angle, side. And therefore, it's similar by side, angle, side. All right, so there's a few different ways to do that. All right, so find QN and PQ. So now we're going to this is talking about angle-angle similarity, which is what I talked about earlier. So now let's go ahead and unsolve for them. So now that we got this, we want to look for x and then x plus 2/4, right? So let me draw out the two triangles. So we got 5, 6, and then x, and then we got this big triangle, which is 8, because 5 plus 3, 9.6, because that's what we got here, remember? And then x plus 2 1/4. Okay, so we got those two triangles, and we want to solve for x, right? And so we can see that x matches up with x plus 2/4. Let's just write this as a decimal, shall we? 2 1/4 is the same thing as 2.25. Okay, so we got x is to x plus 2.25 as, and then 6 is to 9.6, or you could say 5 is to 8, either one, doesn't matter. Let's do 5 is to 8. 5 is to 8. And then we can cross multiply, butterfly method. So we get 8x equals 5 times x is 5x. 5 times 2.25, we need to figure out what that is. 2.25 is 11.25. So plus 11.25. And then let's subtract both sides by 5x. So we got 3x is equal to 11.25. Divide by 3 on both sides. We get 3.75. Okay, so x has to be 3.75. And then, so we know that this side is 3.75. And then we can plug it into this side to get that one. So x plus 2.25 is 3.75 plus 2.25 is equal to 7. So we know that this is equal to 7. All right, so let's go ahead and fill in the blanks here, so you can kind of see how this looks like. So this is kind of like what we did, cross multiply. That's a 5 there. So what did we get? This is 5x plus 11.25. Subtract 5x on both sides. That's what we did. And then solve it. And we got x is 3.75. Okay. And then we make a substitution. So qn, let's go back to here. Qn is x. And so qn has to be what we just got, right? So qn is 3.75. All right, and then you plug it into here, 3.75 into there, and you get 6. So these are your two answers. All right, hopefully that made sense. Go ahead and pause the video and see if you can try the check. All right, so let's take a look at those the check problem. So are these two triangles similar first off? Well, the answer is yes. We got an angle here, and we got another angle because of vertical angles, right? So angle, angle, and therefore they must be similar. Okay, so you can use that. Now, because they are similar, we can set the sides proportional in order to solve. Okay, so we're going to say, okay, this side, 8 matches up. What does 8 match up with? Well, 8 matches up with 10, and x plus 6 matches up with 2x plus 6, right? And so we're going to say, okay, x plus 6, and yeah, so that x plus 6 matches up with 2x plus 6, and 8 matches up with 10. And so we can cross multiply and solve. So we get 10 times x plus 10 times 6, which is 60. 8 times 2x, and then 8 times 6 is 48. All right, and we're going to subtract 10x on both sides, and then subtract 48 on both sides. So we get 12 is equal to 6x divided by 6. So x is equal to 2. So make sure you plug it into there and there, right? So we get 2 plus 6 is 8. And then RT, 2 times 2 plus 6 is 12, or 4 plus 6 is 10. Those are 2 answers. Okay, hopefully that made sense. Let's look at the next one here. All right, so example 3, use similar triangles to solve problems. Julie is designing an A-frame house. The entire house will be 40 feet tall, and the base of the house will be 60 feet long. She will build a second floor balcony along the front of the house, 15 feet above the ground. The left side of the house will be 50 feet long, and the balcony will intersect the side 18.75 feet from the bottom. The peak of the house is directly above the midpoints of the base of the house and the balcony. Calculate the total length of the balcony. Okay, so it says create a model. You can model the sides. So now they said that this height here is 60 feet, right? And then they said that this is 30 feet. Well, or no, it was, I'm sorry, let me see. Let me go back. It says 40 feet tall. I'm sorry, 40 feet tall. And the base is 60 feet tall. Well, if the base is 60 feet tall, then this has to be 30, half of that, right? And so we have ourselves this triangle right here, which is a 60, 40 feet and then 30 feet. So that's one right here, 40 feet, 30 feet. And they said the left side of the house would be 50 feet long. So that's that triangle there. Okay. And then it says the balcony would intersect the side 18.75 feet from the bottom. So that means that this balcony intersects where this right here is 18.75 feet. Well, if that's 18.75 feet, then this here has to be 50 minus 18.75, which is 32.25. Okay, hopefully that made sense. So we got 32.25. And so we got ourselves another triangle like that. Okay, so this is how they got this, well, 30, I said 32, I should say 31.25. So that's how they got the 31.25. And we know that this is the halfway point. So half, the height here is, oh, okay, and then it says here, the left side of the house will be, it says that the second floor balcony will be 15 feet above the ground. Okay, so that means that this is 15 feet, which means that this here is 40 minus 15. Okay, so 40 minus 15, which is 25. Okay, good. So we got ourselves our model, right? Let's see. Okay, so we got ourselves this green triangle, which is this one right here, right? 31.25 and 25. Okay, so I wanted to show you where those triangles came from in the problem. So that way you get an idea. Where did we come up with these sides? So we got our model. Use the information you know to label the triangles. Step 3, describe the model. So here we're looking for, calculate the total length of the balcony. So we want the total length of the balcony, which is this length right here, right? We want to figure out that total length. And so like if I get this side right here, right, the X side, I can double it and get the total length of the balcony because these are both X, right? So hopefully that makes sense. So let's go ahead and solve for X. So we know that 50, so let's say 50 matches up with 31.25 as 30 matches up with X. And then we can cross multiply in order to solve. So we get 50x is equal to, I wonder if they have that in the steps here. Okay, yeah. So 50x is equal to, let's do 30 times 31.25. So 937.5. Okay, let's get rid of that. Then divide both sides by 50. So x is equal to 18.75. Okay, which is what they got there. But remember that this is the halfway point, so we got to double it to get the total length. Okay, so we got to do 2 times 18.75 or 37.5 feet. Okay, go ahead and pause the video and see if you can try to check. Okay, so when you set up this problem, it's good to just draw the situation. So let's draw the scenario. So here we have, it says when serving, he stands 12 feet away from the net. The net is 3 feet tall and he's standing 12 feet away. So let's just draw a net that's 3 feet tall and then he's 12 feet away. It says the ball is served from a height of 7.5 feet. So let's just draw a height 7.5 and then it's served and then the ball goes to the ground. It says he thinks the ball travels 21.4 feet. So he thinks that it travels that much, 21.4 feet, before it hits the ground, 8 feet from the net. So, okay, from here to here, and then from here to here is 8 feet from the net. How far does the ball travel before it reaches the net? So they're looking for this distance. Okay, so notice that there's 2 triangles here. There's this right triangle, there's this right triangle here. So these 2 triangles are similar. So if I look at this big one is 7.5 and 20, and it's 21.4. This small one is 3, 8, and then we'll call this x. Okay, so we'll call this part x. All right, so once we set up similar triangles and we solve for x, we can get this question mark because once we know that x is, for example, 10, then we can subtract that from 21.4 and get our answer. All right, so how far does the ball travel before it reaches the net? There's a lot of, so we'll be able to answer part A. So we're going to say that, okay, we know that 21.4 matches up with x. We know that 20 or 7.5 matches up with 3. Or you could say 20 matches up with 8. So let's do that. 20 matches up with 8. Okay, so we got 21.4 is to x as 20 is to 8. Then we can cross multiply. So we get, so let's figure out what that is. 21.4 times 8 is 171.2. So we get 20x is equal to 171.2. Divide by 20 on both sides. So we get 8.56. Okay, so we know the distance is 8.56 feet for this distance here, which means that the other distance has to be 21.4 minus 8.56, okay? So let's do that. 21.4 minus 8.56. Okay, so we got 12.84 feet. So it looks like 12.84 feet or 12.8 feet. This is round to the nearest tenth, so 12.84 feet. So then our final answer is 12.8 feet. Okay, so what assumptions did we have to make for that problem? Well, there's a few things. We have to assume that the ball traveled in a straight line, right? Normally balls, when they're in the air, they curve like this, right? But here we assume that it travels in a straight line. So we assume ball travels straight. And we also assume that it barely touched the net. So it just went above the net in my picture. And that it just passed the net. We also assume that this angle is right? assume the angle is a right angle between the net and the ground. And so on. Okay, so there's a lot of assumptions that made its way into this type of problem. All right, hopefully you found this video useful and informative. As usual, I'll see you in the next one.